Hello, this is Jonathan here today, working with Cisco Packet Tracer again. Today we're going to be doing an activity on creating a baseline. Our objectives are to create a performance baseline and create a configuration baseline. Background is, as the network administrator for the XYZ company, you have been tasked to create a baseline for the newly installed network. Router 0 has just been installed and configured to support a new satellite office. Use ping and trace route to create a baseline. This lab does not require configuration, so grading will be conducted the completion is already 100% because the configurations are already all correct. So step 1, create a performance baseline. So using the baseline chart or scrap piece of paper, you would identify the following information. Right here, you type in the average round trip time and the path for PC2 to PC0 when you ping it, and then trace route is just where it goes. Select PC2, execute a ping and trace route to each of the devices in the chart below. So we're going to click PC2. Alright, we got PC2 open. Open up PC0, desktop, command prompt, desktop, configuration. We're going to go ping 192.168, or whoops. Ping 10.10.10.2. Okay. It's going to time out the first one. And we got the other three, so we have to ping it again. Ping 10.10.10.2. Okay, now we got all 4 replies. Yep. Now we got all 4 replies. Now instead of just going through and writing it all in, I'm just going to tell you as I go for this activity the time. It says approximate round trip times is in milliseconds. So minimum is 0 milliseconds, maximum is 5 milliseconds. The average is 1 millisecond. So the average for out of these 4 pings is 5 milliseconds from PC2 to PC0, and 1 millisecond is the average. The maximum is 5 milliseconds. So just a little over a millisecond per reply. So now we're gonna go ping PC2 to PC1. So PC1's way over here. So this one might take a little bit longer. So ping 10.10.10 or .20.20.2. Now I'm going to request the first one's going to request timed out. Alright, let's ping it again. Ping 10.10.20.2. Okay, now we got all 4 replies right off the bat. Yep. And then the same thing for this one. We're going to talk about the round trip. Minimum was 0 milliseconds. The maximum on this one was 5 milliseconds as well. The average though was 2 milliseconds. So just a hair longer on this one because it has to go through the switch 4, router 0, router 5, router 4 to switch 1 to PC1. Straight across, or can go down to the switch 4 through router 0 all the way down to router 1, router 2, router 3, up through router 4, switch 1 to PC1. It can do that, or it can just go from PC2, switch 4, router 0, all the way down to router 3, up to router 4, through the switch 1 and the PC1. It takes multiple different ways for that one. And I didn't talk about PC2 to PC0 route. So it can go from PC2 to switch 4 to router 0 to router 1 to switch 0 to PC0. That's what it would take from that. Okay, now we're going to go ping PC3. PC3 is a little closer, but still has a bit of a way to go. So ping 10.10.30.2. Now the first one's going to time out like always. Most times you have to do it twice. So alright, ping 10.10.30.2. Alright, now we got all 4 replies. Same, this one now, this one has a minimum of 0 milliseconds and a maximum of 3 milliseconds because it's much closer to PC2. And an average of 1 millisecond. So there's almost less than 1 millisecond per reply on this one. There actually is, just barely. Now, if it was 4 milliseconds with an average of 1 millisecond, that would mean 1 millisecond per reply. But since it's at maximum of 3 milliseconds, one of those replies was less than 1 millisecond. That one's a lot faster. It's a little closer. So we got that. We just pinged PC3. Now we're gonna ping PC4. A little further away. Has to go through a lot more junk to get to the till you could get to this one. So ping 10.10.50.2. It's gonna time out. We're gonna have to redo the ping. Ping 10.10.50.2. Okay, we got reply. Alright. Whoa, this one has to go through a lot of junk to get to PC4. Take multiple different ways. We got a maximum of 16 milliseconds, an average of 4 milliseconds. That's 4 milliseconds per ping, per reply, I mean. So, see, you got before 8, 12, 16. For that one's a long one. That one took a while to go through. Has to go through a lot of junk to get to send hello packets or receive hello packets from that one, or for the connection for that. Now we got PC5, which is the last one we're gonna ping. So this is the last computer we're gonna ping for now. So ping 192.1. Oh, whoops. Keep thinking 192. Usually that's what IP address is. 10.10.60.2. Oh, whoops. Ping 10.10.60.2. Alright. It's going to request a timeout, the first one. We'll receive the other three, like always. Ping 10.10.60.2. Alright. The first reply is usually always the fastest most of the time. Now see, this one's maximum of 14 milliseconds with an average of 8 milliseconds. So that's about 6, close to 4 maybe. Between 4 and 6 milliseconds per reply. That's kind of slow. It's not getting there that well. So now we've pinged all those. We got our baseline chart and we did the average round trip. And now we're going to talk about the paths that these will take. So we'll go open up PC again, open up the command prompt. I don't know why I closed it. So now we're going to go back and we're going to go trace route, tracert to PC0, and we're going to talk about the route that it takes to get to the destination. 10.10.10.2. Okay, now I pulled up the trace route from PC2 to PC0, and see right there, I'm at trace route to 10.10.10.2 over a maximum of 30 hops. So 1, 0 milliseconds, 0 milliseconds, and then 1 millisecond to get to 10.10.40.1, and then 1 millisecond to get to 192.168.254.33, which would be this router right here. See, we're going for PC2 to PC0. Yeah. Okay. And then let's see here. Do that again. Yeah, and then 2 milliseconds to get out of there. Alright. There's that one. Did it twice just to see. Now we're going to trace route PC2 to PC1. Alright. Go. Tracert 10.10.20.2. Alright. See, now we got 4. See, the first one only has 3 things to go through to get to PC2. From PC0 it goes to the switch, to the router, all the way down to router, then here to there. That's all it does. That's the fastest one you'll have. And then this one's PC2 to PC1, and that's PC1 way across the network over there. This could be a big building, you know. It could be having to scramble all the way over there. So, you know, we got a maximum of over 30 hops for the tracing route of 10.10 to 10.10.20.2. And on the fourth one, we got 11 milliseconds and 1 millisecond on the third one for the IP address. See, this one's going from switch 2 through router 0 through router 5 through router 4 and then to PC1. The 192 IP addresses are these routers right here. Excuse me. Okay. So now we're done with that one. Now we're going to ping PC3, which is somewhat that's the one that had the most junk to go through to get to it. So we'll go tracert 10.10.30.2. All right. Now this one went pretty fast through this tracer. We went from PC2 through switch 4 to router 0, down to router 1, through into the switch 3, and into PC3. That's the route for that. Or, you know, it could go all the way over here and down, across, but it takes the fastest path. So router 0, router 1, switch 3, PC3. For that one, pretty quick. All right. Now see. Now PC4 is right here. It might be that one might be a little bit of a way out there. Let's see. 10.10.50.2. 4. Okay, goes through 4 things. Let's find out. See, we got PC2 right here. We're trying to get the PC4 down here, so we'll go through switch 4 through router 0, down the router 1, crossed over to router 2, down through switch 2 into PC4, or it'll go from PC2 to switch 4 to router 0 to router 5, router 4 down to router 3, crossed back to router 2, down to switch 2 into PC4. It's a little bit of a longer path, but it could go that way. And it also, we could go switch 4, router 0, hop down, router 2, switch 2, PC4, or from PC2 to switch 4 to router 0, down across to router 3, across to router 2, and then down across to PC4. Or we could go switch straight across, jump right across router 5, switch 2, PC4. But it probably would go from, this is the one it would take, switch 4, router 0, router 1, router 2, switch 2, PC4. That's more likely the one it would take. So now we'll go PC5. Wow, PC5 is way out there in no man's land on this network from PC2. So tracert 10.10.60.2. Alright. Yeah, this is the longest route. 11 milliseconds, 9 milliseconds, 11, 11, 2. This one has a ways to go. This one is the big guy. It takes a while to get over there. Okay, so we'll go from PC2 to switch 4 to router 0, down to router 1 to router 2 to router 3 through switch 5 into PC5. Notice each of these PCs have their own switch. Most times, you know, you can connect all these PCs off of one switch, but each of these PCs have their own switch and they're all connected to server. And then from these switches, each of these switches have their own router. So there's PCs have their own switch and their own router that are all intertwined together and meant to connect back up to the server. So this right here is just a basic network for, you'd say, you know, maybe like a school building or a small business. But you still don't know how big the building is. That's the thing. This network could be, you know, a basic network, but the building could be humongous, could be gigantic. So now we did the trace route. We're going to go over here. We're going to go down to step 2. We're going to create a configuration baseline. Now we're going to document the client configurations. Alright, now we're going to go into router 0. Hit the CLI. We're going to go to enable to get into privilege exec mode. Or not, yeah, privilege exec mode. And we're going to pull up. We're going to do client IP range, subnet mask default gateway. We're going to type in show run. Okay, this will show us what we got going right here. Interface fast Ethernet 00 is going and up. Interface fast Ethernet 0/1 is up and going. Interface Ethernet 0/3/0 is up and going. Interface serial 1/0 is up and going. Interface serial 1/1 is not going, or is going. Nope, it's shut down. And serial 1/2 is shut down. Serial 1/3 is shut down. VLAN 1 is shut down. Now, EIGRP 10, no auto summary is set, means these are all went in and put in handheld. I'll manually put in these network addresses for the router EIGRP 10. Now there's that magic number 10 again. That's most the number you'll use when you're messing with EIGRP 10. That's the anonymous number. So these networks, they all have their IP address, but then they got the wildcard 0.0.0.3. All of them have that, except for this one. This one has .255, which is the broadcast of the subnet mask. IP is classless, linecon 0, line VTY 0 through 4 login. Alright, those are the client configurations that we have set up. We're going to go show IP. Oh, whoops. Alright, so now that we talked about, I skipped this A step. We already did this on accident. I skipped this. We're going to have to Alright, we're going to save the startup configuration to the TFTP server. We're going to go copy startup config TFTP. Alright, now that's saved. Destination file name, router config, address or name, remote host, right? Oh, whoops. We got to redo that. Copy startup config TFTP. The host would be, we're saving it to, is router 0 config baseline. Yep, config baseline. Alright, there we go. Alright, router 0 config baseline. Enter. Alright, now we got that set up. Now go to PC2, where we all started at, well, see here, it all starts at PC0, actually. We're going to talk about the document the client configurations, subnet masks and default gateways, and the IP client IP range. So PC0, we'll go into IP configuration. Notice it goes 10.10.10.2. That's where it starts. Of course, you have the two networks, your two IP addresses you wouldn't use for broadcast and the host IP addresses. So .10 is where it starts. You go all the way to PC5 and click IP configuration. It goes 10.10.60.2. So it goes up 10 for each one. So 10, 20, 30, 40, 50, 60. Except it starts at 10, 20, 30, 40, 50, 60. So, and then that's the IP addresses. The subnet masks. Oh, whoops. PC0 subnet mask is 255.255.255.0. Should be that on all of them. Same as that one. That one's got the same one. That one's got the same subnet mask. They're all a subnet mask of 255.255.255.0 on the PCs. Yep. Now if you go in, see if it'll let us. Okay, it will. It'll let us go into it. Settings, let's see here. Let's try the router here. We can't, won't let us go into that router. About this one, let's go into the config. No, we can't go into the config of that, and we can't, won't let us talk about the settings on the routers for some reason. It's kicking me out. Alright. Default gateway 10.10.10.1, 10.10.40.1. Now these are going to be the same thing. They're going to go up 10 per thing. 10.10.30.1, they're going to go up 10 per connection or per PC. 10.10.50.1, 10.10.60.1. Now these are the default gateways, which is the part where it exits the computer. 10.10.20.1. Okay. And that's the default gateways, and that's all I have for you on the video of creating a baseline and discussing IP addresses and IP ranges. And also we did something new today which we haven't done before, which was the destination file name. When you actually type in a file name of where you want stuff to be saved, and then the host you want it to be saved, the name of the remote host, which we haven't went over that yet before, but you know what? Let's go in there and let's do that again. Let's go do that again. I want to get a better idea of that. So let's go copy startup config TFTP. Name of the host will be 10.10.40.250 subnet mask. Okay, and then router 0 underscore config underscore baseline. Alright, now it's writing the startup configuration. Now that's good. Now we have that set up. Everything that's gonna, this was router 0, which is the main router. This is this, we set it up to where that's the host. That's the remote host, 10.10.10.40.250. So router 0 is the main host of all these, has the highest IP address. He's the big head honcho. Everything goes through him. He sends out updates. He receives everything. Router 1 can't send out. Router 2 can't send out. Router 3 can't send out. Router 4 can't. They can't just go. Those other routers can't send nothing out. Only router 0 can send it all out to these guys. However, if this guy were to go down, the next guy with the next higher IP address, which would be router 1, would come up and he'd be the main guy. And then when router 0 came back online, it wouldn't matter. He'd still be into the mix with the rest of the guys. This guy would be the head guy still, even if when he came back online. So then router 1 would send out other stuff. Now, if router 1 went down, and then router 0 would be back to the main guy because he had next higher IP address, and router 1, when he come back online, would be in the mix still. He wouldn't be anything. And that's all I have for you today. Hope you learned a little something today on my video with working with Cisco Packet Tracer and creating a baseline. Notice the completion is 100%, and thank you. Have a nice night.